All right, in this segment, we're going to talk about some operations with polynomials. All right. First thing we might want to do is define what a polynomial is, just a brief definition. When you're talking about a polynomial, you're talking about one or more monomials. A monomial would be one term. So if you put, a monomial could be a polynomial. If you put two monomials together, you get a binomial. Put three of them together, you get a trinomial, and so forth. The common ones, though, will be monomials, binomials, and trinomials. They're still all polynomials. You want to think of them kind of like Ford cars. You got Ford brand, but you have different kind of cars. You have Mustangs, F-150s, Rangers, whatever, but they're all still Fords. You have monomials, binomials, and trinomials, but they're all still just examples of polynomials, all right? One other thing you might want to consider that would be very helpful is whenever you write a polynomial down, I would encourage you to write it in standard form. And when you do that, when you think standard form, you want to think of doing it in descending order of exponents. So for example, if I had 4x cubed minus 9x squared plus 13x minus 12, that would be a good example of a polynomial in standard form because we have exponents going in descending order, 3, 2, 1, and technically you have an exponent down there at the end with a value of 0. All right. So now that we've kind of explained what a polynomial is, we're going to talk a little. We're going to do a little bit an addition, a subtraction, and maybe a couple of multiplications. All right. So let's start with first of all how you might add one. So what if you wanted to add these two polynomials? What if you had 6x squared plus 2x minus 4, and you wanted to add to it negative 8x squared plus x minus 3? All right. Parentheses aren't totally necessary here. They're really just giving you some parentheses just to say, hey, we're adding this trinomial plus this trinomial, right? So when you're adding and subtracting, I would encourage you to rewrite this without parentheses first, all right? You could argue that there's a positive 1 here that you're going to distribute through this polynomial, but it's not going to change anything. So what you'd want to do is just write them down first without the parentheses. And again, you're distributing a positive 1 there, so no signs change. So now that I've done that, I've got it without parentheses. Now we're free to do what's called combining like terms, right? We want to put the squared terms together, the x terms together, and your constants together. So if I were you, I would rewrite. We can have 6x squared plus negative 8x squared. We'll put them together. Then we'll go to plus 2x, and it'll go with plus x. They're like terms. And then we'll finish up with our constants. We have minus 4 and then minus 3. And you can lightly scratch through them like that just to make sure you get all your terms accounted for. All right, so now you want to add them up. If I have 6x squareds and negative 8x squareds, we're going to end up with a negative 2x squared. 2x and x would add up to 3x, and then minus 4 minus 3 would give us minus 7. And if you organize it that way, then we have a nice polynomial down here that is in standard form, okay? So in other words, when we sum these two trinomials, our answer would be negative 2x squared plus 3x minus 7. All right, so that's an example of addition. How about a subtraction one? So what if we had to subtract, what if we had 2x squared plus 3x minus 1 minus, and then we had another trinomial that's x squared plus 5x minus 8. Want to approach it much the same way. This one we have to be a bit more careful because if we're doing this trinomial minus this trinomial, the term minus means opposite of. So we have to take the opposite of everything in here. In other words, it's kind of like distributing a negative 1. Some people will take a different color marker and put yourself a 1 right there to tell yourself that you're distributing a minus 1 through there. This first polynomial is going to stay like it is. But if I distribute a negative 1, the opposite of x squared would make that minus x squared. Opposite of plus 5x would turn that to minus 5x. The opposite of plus 8 would turn that to minus 8, right? So again, rewrite it without parentheses in addition and subtraction, right? So now we want to combine like terms again. So we're going to have 2x squared. It's going to go together with minus x squared. Taking care of them. We have plus 3x and a minus 5x. And then we have a minus 1 and a minus 8 go together. Now we have all our like terms grouped. So if we put them together, 2x squared minus x squared would just give us an x squared. 3x minus 5x would be minus 2x. And then negative 1 minus 8 more would be minus 9. So our resulting polynomial here would be x squared minus 2x minus 9. So before we do a multiplication, just remember, whenever you're doing addition and subtraction of polynomials, please remember, rewrite them without parentheses first, whether it's addition or subtraction, and then just think combined like terms, all right? Now, how about a couple of multiplications? Really 3 things you want to think about here. Here's a first example. What if we just had to do a monomial distributed through some type of polynomial here? We'll use a binomial, for example, here. What you're going to want to do here is you're going to want to think distributive property. We've got to take 3x out here and multiply it times everything in parentheses here. So you're essentially thinking 3x times 2x there, and then 3x times 4. You can write it out that way if you like. You want to do everything in the parentheses times what's out in front. 3x times 2x, 3 times 2 would be 6. X times x would be x squared according to the laws of exponents. Plus, if you have 3x times 4 here, 4 times 3 would be 12x. So if you have a monomial times a binomial, you just want to think that monomial being distributed through or multiplied by everything that you have in parentheses. All right? Now, another variety. And this will use the distributive property as well. What if we had to multiply? What if we had x plus 2 times x squared minus 3x plus 5? All right, so what if we get into some polynomials being multiplied together? This is an example of a binomial times a trinomial. What you need to make happen is we just need to make sure we multiply both parts of this binomial times all 3 parts of that trinomial. There are many ways to do it, but what I would do is just break up this binomial and multiply each part times your trinomial. So I would take this x from this binomial, and we're going to multiply it times this trinomial, and then we're going to take this 2 and multiply it times that trinomial. And what we're going to do here is we're just going to end up distributing, just like we did over here when we did a monomial times a polynomial. X times x squared would be x cubed. X times minus 3x would be minus 3x squared. X times 5 would be plus 5x. And if you arrange it like this, now I can collect like terms, or I can create columns of like terms. If I did 2 times x squared, that would be 2x squared, which I would want to line up with this negative 3x squared I had in my other multiplication. 2 times minus 3x would be minus 6x, which I would line up with the 5x from the previous distribution. 2 times 5 would be plus 10. And if I do it this way, I can add like terms here. And you want to think, whenever you're combining like terms, you're adding. So if it helps, you put a little addition sign in each column here. So if I add x cubed plus nothing else, that's just going to stay x cubed. Negative 3x squared plus 2x squared would make that a minus 1x squared, or just minus x squared. 5x plus a negative 6x would just be a minus 1x or minus x. And then I have no constants up here, plus a 10 down here would leave me with just 10. So our resulting polynomial here is x cubed minus x squared minus x plus 10. There are many ways to do it, but if you do it this way, it helps you kind of organize and create columns of like terms. So that's an example of a binomial times a trinomial. The last one we want to try is what if you had to do just 2 binomials? For example, what if I had to multiply 2x minus 5 times 3x plus 4, all right? I would approach it much the same way we did this one. We just need to make sure we do both parts of this binomial times both parts of that one. Some people use what's called the FOIL method. You can do that if you like. Or we can just set it up like this. We can say, hey, we need to do 2x times 3x plus 4, and we'll get that. Then we need to do this minus 5 times the same binomial, 3x plus 4. And if we write it out like this, we can arrange it. 2x times 3x would be 6x squared. 2x times 4 would be 8x. When I go down here, I've got negative 5 times 3x would be negative 15x, which I'd want to line up with this x term here, because these are going to be like terms. Negative 5 times 4 would be minus 20, right? Now again, if I do it that way, I've got everything lined up and organized. Again, you want to think combining like terms. So you want to think addition. 6x squared plus no other x squareds would just be 6x squared. 8x plus negative 15x would be minus 7x. Nothing plus a minus 20 would be minus 20. And if you do it that way, again, it gets you into nice standard form. All right, so we just talked about some operations of polynomials. Our next segment will deal with factoring.